Okay, here's some more examples on how to draw Lewis electron dot diagrams. So I'm going to do all of example 2 together, and then I'll go to example 3, and we'll do those ones together as well. So remember, step number 1 is count the valence electrons for the whole molecule. So sulfur has 6, oxygen has 6, there's 3 of them, so that's 18. And then with that minus 2, remember, we're just going to add 2 more at the very end, so that's 26. Nitrogen has 5, there's 2 nitrogens, so that's 10 all total. Sulfur has 6, fluorine has 7, 7 times 4 is 28, so 6 plus 28 is 34. And then oxygen has 6, there's 3 oxygens, so that's 18 all total. Okay, step number 2 is put 1 in the center, put everything else around it. So I'm going to put the sulfur in the middle, put the 3 oxygens around it. With N2, it doesn't matter which one's in the, quote, middle. So I'm just going to put them just next to each other. Which one's in the middle and which one's not, it doesn't matter. SF4, 1, 2, 3, 4 fluorines around the sulfur. Oxygen, again, there's 3 of them. Which one goes in the middle? Well, they're all the same. So let's just kind of put them in a nice little cute row like that. Okay, the next step says to make a single bond between the central atom and each of the outer atoms. So I'm going to place a single bond, just one single bond in N2, and then again a single bond here, and single bonds there. Okay, then the next step says to put 6 dots around each of the outer atoms to complete the octet for them. So I'm going to put 6 dots around each of those. Remember, there is no hydrogen on this one. We'll see hydrogen down here. But remember, with hydrogen, you never ever put dots on hydrogen. So I'm going to put 6 dots on each of those. Now, of those oxygens. So that one's done. Now on N2, which again, just choose one and make it the outer atom. Okay, so we're done. I just chose the right one to be the outer atom. Doesn't matter. Okay, 6 dots on each of the fluorines. Okay, so that one is done, and then again, oxygen O3 is actually the chemical formula of ozone, like the ozone layer is O3. Okay, so we're done with that step. Okay, the next step says that if electrons are left over, you must place them on the central atom. So I have 26. Real quickly, 8 times 3 is 24. I've used 24. Remember, 8, 8, and 8 makes 24. So I've used 24. I have 2 left over. Where do they have to go? They have to go on the central atom. Okay, don't mix these last 2 steps up. They're really, really important to making sure you get these right. Okay, on N2, I've used, again, 2, 4, 6, 8 electrons, but I have 10. So I still have 2 that are left over, so I'm going to put them, I made the nitrogen on the left, so I'm going to put them on there. Okay, with SF4, I have 34. I've used 8 times 4 is 32. I have 2 left over. Put them on the central atom. And on O3, 8 times 2 is 16, so I've used 16, but I have 18, so again, I have 2 left over. Okay. Now, the very last step is if the central doesn't have 8, then we've got to move electrons in from one of the outer atoms to make sure it has 8. Okay? Look at SO3 2 minus. The sulfur has 2, 4, 6, 8. Okay? And again, I put that there to help you count those up, but when you're done, don't leave those there. Okay? And what that means is we're done. That one is finished. Okay, on SF4, the sulfur has, count the bonds, each bond counts as 2, plus the 2 dots on the sulfur. That sulfur right here actually has 10 electrons on it. Okay, so if it has 8 or more, then you're good. Okay, so that one is done. Okay, we'll come back to nitrogen here in just a second. What about O3 though? Okay, this oxygen here in the center only has 2, 4, 6 electrons. Okay, it's missing 2. Okay, so what do? Again, it doesn't matter. Just choose one side or the other. Take 2 electrons away. and move them from there into the bonding region to make a double bond. And now the oxygen on this oxygen out here has 8, 2, 4, 6, 8. Okay, because again, each bond counts as 2, and that one now has 8. But now that central atom also has, count them, 2, 4, 6, 8 electrons. Okay, so everything is good on that ozone molecule, so that one is done. Now with nitrogen back here, the nitrogen on the right does have 8. The nitrogen on the left, though, only has 4, doesn't it? It's got the 2 dots plus the bond. That only makes 4. So, well, what am I going to do? Well, what I've been taught to do. I take electrons from one of the outer atoms and make a double bond. Okay? Now, this nitrogen here on the right still has 8. Again, count the electrons in the bond for both atoms. Okay, and this nitrogen here now has 6. So it's closer, but it doesn't quite have 8 yet. Okay, so what do? We have to keep moving electrons. And again, just the way that I chose it, I made this one the central atom, and I made this one the outer atom. So you always take electrons from one of the outer atoms. So what do we have to do? We have to take 2 more electrons from out here and move them into the bonding region. And now you'll see that this nitrogen on the right has 8, 6 in the bonding region, 2 just out on that nitrogen, and this nitrogen now also has 8. Okay, and that is the correct chemical drawing of the nitrogen molecule. Okay, and nitrogen, yes, does have a triple bond in it. It's really, really strong. It's really, really hard to break. Okay, most of what we breathe, about 78% of air, is nitrogen. Okay, so almost 80% of what goes into our lungs is nitrogen. But because of that really, really strong triple bond, our lungs and our blood doesn't have the ability to do anything with that. And so the nitrogen goes into our lungs, the nitrogen goes out of our lungs, okay? That's also why you see old people or people that are at a football game or an athletic event, they'll sometimes will put a mask on because that mask will contain pure oxygen. So instead of your body, instead of 80% of what's going into your lungs being nitrogen, it's all oxygen, and your body can recuperate faster and, keeps people healthier, get you back into the game quicker, etc. Okay, and so that's it for those 4. Okay, let's move on here. We've got these 4. So again, let's start at our first steps again. CO2, 4. Carbon has 4. Oxygen has 6. There's 2 of them. That's 12. 16 electrons. I'm going to move a little bit quicker on these. 5 plus 3 is 8. 5 plus 35 is 40, and 8 plus 24 equals 32. Okay, now I'm going to put 1 in the center, put the other ones around them. 1 in the center, other ones around them. Move that away a little bit more. Okay, PCl5, gross. Okay, 1 in the center, yep, and I'm going to put everything else. Even though I'm trying to get to 8, remember, sometimes you don't have a choice. Now, N2O4, something like this, I would help you. I would say, okay, this is how you draw it. You put the 2 N's, and then you put an O and an O. So I would draw this part here for you, and then you just got to do the rest. Okay, I wouldn't expect you to be able to draw that. Okay, then we place a single bond between the outer atom and the central atom. Now here, basically, we are going to put a bond between the 2 nitrogens as well. Okay. And again, this one's a little bit odd in that it doesn't have 1 central atom, it has 2, but we still have to connect them together. Okay, and then we're going to complete the octet for the outer atoms, so I'm going to put 6 dots on everything that's not hydrogen. Oh, hydrogen. No dots on those hydrogens, but all the chlorines. Kind of going a little bit quicker here. Hopefully you can see those dots. I'm putting 6 dots on each of the chlorines. Okay, outer atoms here as well. 6 dots on each. Okay, and so each of those now have 6 dots on them, plus the bond makes 8. Okay, and now we check to make sure, does the central atom, have we used all of our electrons? Okay, so we've used 8 here, that's 16. We have none left over. So that's it for that step. Okay, NH3, we've used 6. Each bond is 2. We have 2 left over. So I'm going to put them on the N. PCl5, we had 40 electrons. We've used all 40 of them. We don't have any left over. And on N2O4, I feel like I did that wrong, didn't I? Yeah, I did. Hopefully you caught that. Nitrogen, that's what I get for going fast, right? Nitrogen has 10. Sorry, nitrogen has 5 and there's 2 of them, so that's 10. Okay, so that should be 34 electrons. Okay, so I have 2 that are left over because I have 8 times 4 is 32. So I'm going to put 2 electrons on just one of those central atoms. Again, I'm just following the steps, right? Okay, now my last step is if the central doesn't have at least 8, then I've got to do something to make them have 8. Okay, so I'm just going to go through these real quickly. This one already has 8. The nitrogen has 2, 4, 6, 8. That NH3 molecule is done. That is the Lewis electron dot diagram of, if you ever use ammonia in your house, ammonia, the chemical formula of ammonia is this, NH3. Okay, PCl5, that phosphorus has 2, 4, 6, 8, 10. It has more than 8. So we're done. That one is complete. Okay, let's go back to CO2. Okay, on CO2, the carbon here in the center only has 4, and we need it to have 8. So what we're going to do is we're going to take 2 electrons from one of the oxygens. So hopefully, if it'll let me here, take those 2 and make a double bond. Now the carbon has 6, so we're close. And again, just because I like things to look symmetrical, and it's actually correct too, is you place another double bond on the other side. Now, if you were to do a triple bond and a single bond, I wouldn't mark it wrong, but CO2 actually does have 2 double bonds. Then there's more to the reason why. But that is the correct Lewis electron dot diagram of CO2. Okay, part of the reason why is, remember that oxygen, this is going back a little bit here, ends in 2p, 1, 2, 3, 4. So see how oxygen has 2 spots here where it can make another pair? That's why oxygen generally forms 2 bonds. And so if we can, we try to make it where oxygen almost always forms 2 bonds, but again, a lot of times that just doesn't happen. For example, over here, it's not going to happen at all. So if you can, you try to make oxygen have 2 bonds, but in this case, it's not going to happen. So in this case, with N2O4, you do have this nitrogen here on the left does have 8, but this nitrogen here on the right only has 6. So a real simple solution to that is to take those 2 electrons that we put on that nitrogen, put it in between the 2 nitrogens, and now you should notice that both nitrogens have 8 and 8. So now we are done. That is the complete Lewis electron dot diagram of N2O4. Okay, and if you follow those first 4, if you followed along with these next 8, hopefully you're in really good shape. I will tell you the biggest mistake that I find students make is right here. Steps 5 and step 6. They get to that point and for some reason it's like, I'm done following the rules. I'm going to do it my own way. Okay, follow the steps. Before you start moving electrons around and making double and triple bonds, make sure you've put all of your leftover electrons on the central atom. Okay, and don't ever, ever, ever make double or triple bonds unless you have to. Okay, you only make double or triple bonds when that central atom doesn't have 8 electrons around it. Okay, if it does, you never ever make double or triple bonds. Okay, and those are some more examples there of Lewis electron dot diagrams.